Now, I want to start a new topic this morning, which is on software testing. This week's lab, though, if we go into the previous section, this week's lab is this one here, which is kind of extending the CI pipeline that he built last week, although we'll be using a different application. That's not really relevant, but in this lab, you will be extending the CI pipeline to include continuous deployment. Now, it does mean that you are going to be using your AWS account, Amazon Web Services account in tomorrow's lab. So if you haven't created an account for yourself, you need to do that before tomorrow. And it needs to be your own personal account. For those of you on the SSD side, you would have used an AWS account when you were studying, what was it called? Cloud services, was it in third year? That account, though, if it wasn't your own account, that won't work for this lab. So create your own AWS account before tomorrow. And I will need to give a bit of an intro to this lab tomorrow morning. So I will schedule a Zoom uh, meeting for tomorrow morning as well. I don't think it'll take too long for me to walk through the intro, but I do need to do that. So the new topic is software testing, and this topic will take us to the end of the semester. So if I look into these slides here. And by now, you will have noticed that everything we do is about automation. We like to automate things. We don't like manual tasks because any manual task is prone to error, especially if it's a task that's repeated multiple times. And certainly testing is a task that we need to carry out repeatedly throughout the software development life cycle of a project. Hence, we want to try and automate testing. And in terms of these kind of axioms or mindsets, really, that you need to have as a software developer from a testing perspective, if you ever write application code and you haven't tested it, then your mindset needs to be like this. I haven't tested it, therefore it mustn't be working properly. Or if you are adding some new feature to an existing application, then not only do you test that new feature, but you also rerun or regression test the existing features because it's possible that the new feature that you've added could actually cause some existing functionality to break or not function as expected. And so you should rerun all of your tests for that previous or earlier functionality. That's what's called regression testing. So these are the two kind of mantras that you need to be uh, following when you are following as a software developer. This is the image that we've seen multiple times now, so it's fairly obvious where the testing comes in the whole DevOps process or the whole Agile software development process. There could arguably be some testing done. Uh, sorry, no. Oops. Where do I get my pen? There might be some testing done here, unit testing in particular done here. But certainly the majority of it is done in kind of pre-deployment. And arguably there's some done post-deployment as well. But um, anyway, there's a lot of it going on during the Agile software development lifecycle, stroke DevOps lifecycle. I think you probably know all of this stuff already from previous modules, but just to reinforce it. Uh, Traditionally, anyway, there are kind of a number of different levels of testing. There's unit testing, where the units are essentially the classes. If the code, the application code that you're writing is using a class-based language, then we would call the individual classes units. So you need to write tests for each unit in your application code. If you're not using a class-based language, then presumably it's a functions-based language. So you would write unit tests for each function. So that means that for every unit in your application code, you have to have tests for it. So that's a lot of tests if you think about it for large applications. But anyway, that's unit testing. Integration testing is essentially where you're testing the the integration of your code with any kind of external resources. I'm saying there. So typically that might be integration with external databases, any kind of remote servers that your application may be communicating with, any cloud services that it's communicating with. You clearly need to test those uh, integration points. System testing is where you're testing your entire application as one entity. Yeah. So you would tend to do a lot of system testing once you've got a functioning application. It may not have all of the functionality, but it's kind of functioning from end to end anyway, from the user interface end right to the whatever the back end is. And even if it doesn't have a user interface, like it might only be a web API. There's no front end being developed, but the web API still has an interface, that being the HTTP endpoints that it presents. So system testing is testing your entire application as one entity. And there may be different parts to system testing. Certainly you want to test to make sure that the functionality is working, but you also may need to do performance testing. And it's argued that you should never mix the two. Do your functional testing presumably first. There's no point in doing performance testing if the functionality isn't working. Do your functionality testing first, and don't be concerned with performance issues. Then move on to performance testing. Performance testing is also referred to as stress testing or volume testing. Some people talk about acceptance testing as being distinct from system testing. Really, the only difference is that acceptance testing is either A, it's actually carried out by the customer or end user, or B, it's essentially testing the entire system. So if you like, it's the customer performing system testing for themselves. Or acceptance testing could also be where you're using test data that's provided by the customer when you're doing your system testing. Okay, so it could be either of those two or some sort of mishmash of the two. Um, that's fine. So I'd say you're familiar with all those terms. And we saw when we were talking about CI/CD that testing was a big part of the whole CI/CD process. Um, so it may not exactly be like this, but there are certainly a lot of testing stages in your pipeline. And we really haven't looked at that at all so far. We probably look at testing uh, in kind of locally first on our desktop and then try and bring it into the CI/CD pipeline. Some principles for testing is certainly testing has been part of software development before we had the Agile methodology. But in the context of an Agile methodology, then when you're talking about testing, you certainly you want to automate it. And so there are actually there's software out there or testing frameworks that we can use to make writing automated tests a little bit easier for us. And that's really what we are going to be predominantly looking at for the remainder of this module, looking at these testing frameworks. Well, one in particular, two actually, sorry. Um, so that's principle number one. You use a testing framework. Don't write all of the tests as separate kind of scripts. Um, Leverage an appropriate testing framework, software framework. All application code must have associated tests. So that really means, right, that for every application code, piece of application code, we need to have a corresponding test code for it. So we're essentially writing two streams of code, our application code and our test code. And the test code can sometimes even be longer than the application code. And so it's not an insignificant um, task to write automated tests. It is very time consuming, or it can be time consuming. So there better be benefits to it. Otherwise, one wouldn't do it. But so number two, anyway, applies. We have to have quite a lot of tests, as much testing code as our application code. Principle number three, whenever a bug arises in your application code, clearly you fix the bug, but straight away the next thing you do is you write an automated test to prove that the fix is actually working. Okay. Um, uh, okay. Number four, follow what's called the TDD process or test-driven development process. That's something I'll talk a little bit about at the very end. Um, it's not an easy skill to develop, and you certainly won't develop the skill in this module, but you'll certainly have an understanding of what we mean by test-driven development. I wouldn't expect anything more than just that, really. It requires a lot of practice actually to follow this test-driven development approach towards. It's actually an approach towards software development, not so much an approach towards testing. It's a software development approach. And so as a result of all of these principles, provided we follow these principles, then the benefits that we get are down here. Okay. Fewer bugs, identifying bugs much earlier than uh, if we weren't using an agile software development approach. Developing code that always works. If you're always writing tests, every time you write some application code, you write some test code to prove that your application code is working, then you always have some working code. It may not be complete. It may still have some bugs in it, but at least it works under normal kind of circumstances. The scheduled slippage does not equal less testing. That's really a throwback to when we were kind of pre the agile software development era, which would be the kind of what's referred to as the waterfall era. I'm sure you're familiar with the waterfall development methodology. And with the waterfall development methodology, we only did testing at the end. We did not do it during implementation. And so what tended to happen back then was if your scheduled deliveries of your application were starting to slip, in other words, you were falling behind in terms of your targets for delivering your application, then what tended to get uh, reduced was the amount of time you spent testing. Whereas if you're following the agile approach towards testing, then that kind of doesn't arise because you're almost writing and doing testing from the very beginning of your software implementation. Code is more maintainable. Okay, it's hard to prove that, but that's probably a consequence of the fact that you're you're doing a lot of testing from very early on because you're identifying bugs very early on, and you're also um, ensuring that your code not only is working but is well structured. That's kind of a consequence of TDD, as it turns out, but we'll come back to that maybe. Uh, uh, I did mention regression testing at the very beginning and just mentioning it here. And so the idea is that when you add some new functionality, um, it's possible that the new functionality that you're adding could actually break existing functionality. Now, you do have tests for that existing functionality. And so the argument is you should rerun those tests for the existing functionality when you're adding new functionality. Clearly, for the new functionality, you will have tests as well, but don't fall into the trap of only running the tests for the new functionality when you've developed it. Rerun the tests for the existing functionality. So essentially, you're constantly you're rerunning quote unquote old test code over and over again. And that's really the main benefit of spending time writing automated tests in the first place. We actually get to reuse them multiple times during the development life cycle, so that their value is increased as a result of that. Because I've already said that it can be time consuming, quite time consuming to write automated tests. So if we're only going to ever run them once, you know, it's hard to justify spending so much time writing them. But in fact, we're going to be rerunning those tests over and over again, and hence that's the payback, if you like, for putting the effort in initially. Uh, okay, so that's just regression testing. It's a term that you just hear. So, uh, okay, so uh, we want to write tests for our application code. Um, how do we ensure that the tests that we write are good tests? Because we could write lots of tests, but they're not really great. They don't really do what they're meant to do, which is to really exercise the functionality to essentially you're looking for bugs when you're writing tests. That should be your mindset. So um, the prerequisite before you can ever write any test code is you've got to have a clear specification of the required behavior, i.e. functionality, of the target. The target is, your application code. So the target could be a class if you're doing unit testing. It could be, a subsystem or a section of your overall system if you're doing kind of system testing. But you have to have a clear specification, and that's presumably some sort of a written document, perhaps with some architecture diagrams or some sort of diagramming included. But it's a specification, and it's clear in terms of how it describes the behavior that you want the application to uh, achieve. Yeah. If you don't have that, then you can't write good tests. That seems obvious, right? But we don't always have clear specifications. And that's why problems arise, is bugs still arise in code. But let's assume that we can achieve that. We can always ensure that we do have good specifications for our uh, targets, our application code. And so when you're writing tests, I'm saying here, against uh, against the specification. So we're actually testing the specification, because if the specification satisfies this requirement, that it's clear and it does actually describe the required behavior, then the test, what it's really trying to do is to ensure that the implementation meets the specification. So even though you might think that when you're writing tests, what you're going to be looking at is the application code and then writing your test code against the application code. Uh, but the application code may not actually honor the specification. And so there's no point in writing tests against the application code and proving that those tests actually work if the application code isn't actually honoring the specification. Uh, so when you're writing tests, it's really the specification that you need to be looking at, and that should be driving the test cases that you're actually implementing. And that is really that's reinforced in this test-driven development methodology, as you'll see at the very end of the set of slides. And sometimes people don't actually get that point. Um, write tests, write tests in terms of, oh yeah, um, this term expectations is something that reoccurs now when we're talking through this topic. You write tests in terms of what you expect the target to do when you give it certain inputs, and the context is also specified for a given context. So that's what your test should sort of be expressing. What expectation, uh, what expected behavior are you hoping from the target if you give it certain inputs and the context is also specified, is also stated, if you like. And we'll see that actually in our test code. So we write tests in terms of the expectations of the target's behavior for a given circumstances and specified inputs. Okay, the example. Again, when you read that example, you kind of get the point of what I mean by expectation. Because the reason we're doing it in this way is because, again, we're writing our tests against the specification. We're not looking at the actual code. We're looking at the specification. The specification is all about describing the behavior of the target. And so our tests should be stating, well, what do we expect the behavior to be of our target? Or more precisely, I suppose, what do we expect the response to be from our target when we give it certain inputs, and the circumstances or the context is also stated. The test target, I've already kind of mentioned this. The test target when you're doing unit testing is the function or class that you're testing, the unit that you're testing. The test target when you're doing system or acceptance testing is the entire application. It's just a term we talk about, the test target. Designing test cases. Okay, so if we think about, so the previous slide was all about talking about the specification. That has to be your starting point. And you're writing tests against the specification. It's almost like you're ignoring the code, because the specification is the ultimate kind of aim that you're trying to uh, deliver to the customer. Often in specifications, when we talk about user requirements analysis, we talk about user stories. I'm sure it's a term that you've heard about when you were studying user requirements analysis, probably back in first year or second year. And user stories, however they're written, they're usually kind of giving this kind of they're expressing an aspect of your application following this given when then kind of structure. The given is stating some sort of context for the user story. The when is stating that some action is carried out on the target, and the then is stating what the response from the target should be. Okay, so the given is stating the context in which you're going to be exercising the target in your test. The when is stating what part of the target are you invoking, and the then is stating what response uh, do you expect back from the target. Now, this given when then kind of structure, you can write user stories following that structure. Okay, and user stories are part of your user requirements analysis, and your user requirements analysis is all about specifying your application. So whether you have them directly, you could certainly extract them from the user requirement specification. You could extract all the various user stories that describe the behavior of the application that you're trying to develop. And if those user stories follow this given, when, then structure, that's going to be very useful to us when we're actually writing tests. So that's just something about user stories. Okay, some examples, always to try and make things a little bit easier to understand. So it looks like this example here is from your kind of standard banking application. So given a bank account is 500 euros in credit, uh, and the debit card limit is set to that. So that's the given part. That's the kind of context or the circumstances. When this action is carried out, then this is the response that we would expect back from our target. And our target, I suppose, in this case is the system, really. This is kind of a user story at the kind of systems level. Here's another user story. I kind of came up with this one because you're doing this movies application in the web app dev. So, and you're developing a web API. So let's say I'm saying, given that the movies database includes 3 movies for this particular actor. And so if one of the features of your application was to allow the user to do a search for movies that included a particular actor, for that particular feature, this would be a user story for that particular feature. So when the user enters this name as the actor that they're interested in, then the response should include the 3 movies from the database, even though the database clearly has other movies. So these are 2 examples of user stories that are following this given, when, then structure. And these user stories are typically part of your user requirements specification. Okay. Sorry, just to go back. And these are going to be very useful to us when we're writing, let's say, system test cases. Because I said, trying to link it back now, I said back here that we test the specification. Oh yeah, we write tests in terms of expectations. So the expectations would be the then part of given, when, then. The given part would be, our database has 100 movies in it, and 3 of them relate to Cillian Murphy. The when part would be when the user wants to do a search of the movies database for movies that include a particular actor. And the then part is stating what the response should be when we specify a particular actor. Now, the user stories in the previous slide were kind of at the system or application level, but you could also follow that same given, when, then approach to unit testing. So I'm saying the given, when, then also applies to unit testing. And so a very simple example, again, it's kind of a made up example. Let's suppose this is a function. which is a unit uh, in my uh, in my application. And this function, you give it a region, and it's meant to return certain students from a student array. Okay. And the student array contains records about each student, including their kind of address, let's say. So this get by region function, and I'm kind of giving you its specification now narratively. I mean, I could have written it out, but narratively, the idea is that the region could be set to county, and in that case, the function needs to identify all Irish students in this case and pick out the counties of those students and return that data in some sort of object structure. Or the region could specify a country, or thirdly, the region could specify a continent, and the response back from it would be according to whatever region parameter it received. So in terms of our given when then, I'm saying given that the array has, let's say, the following content, it has 10 students from Wexford, 20 students from Waterford, 2 Spanish students, and 12 Chinese students. So that's the given part. When the region is set to county, so we're invoking our function with county as the region, let's say as a string, then the result should be, let's say, this. Now, in the specification for this method, the specification would state that the result has to be returned as an object with key value pairs, and the key value pairs depends on really what the region input was. And when the region input is county, then the response, the keys in the object should be the counties. I'm giving you all of that kind of orally now, but that would be in this actual specification. The specification would also, so that's the given when then, or that is one given when then scenario for our target. Another would be, I've left out the given part, but the given part would be the exact same. Here's another given when then. The when though is now saying that the region is set to continent, and the then would say that, look, this is what I expect the response to be. To use that term again, my expectation, I expect the response to be exactly this. So these are two good basis for writing test cases for this target function. And really, all I'm trying to get across here is think in terms of this given when then structure. You don't have to actually write it all out, but you should certainly think along that approach. So it's all a bit theoretical. Let's try and move to practical application of all of this. So I want to move down to the unit testing part of uh, the various testing levels, sorry, of testing. And we want to obviously look at automated of unit testing. Now the logo here, Mocha, this is the framework that we're going to be using. So Mocha is it's not just a unit testing framework, it's a testing framework for JavaScript based applications. Yeah. And as a context, we're going to use a class called the catalog class. So if I switch over to VS Code, so this is my little mini project, and at the moment I've only got 2 classes in my source application. I've got a product class, okay, which only has a constructor. So a product is something that has an ID, a name, a price, a quantity in stock, and a reorder level. Okay, so it's just a basic, trivial class. Clearly, we do not need to write any unit tests for this class. I've also got a catalog class, and this catalog class has lots of methods, but in terms of its constructor, a catalog has a title, and a catalog has a products, which is an array. And as you might gather, this array would be an array of product instances. And then I've got various methods associated with this catalog class. Yeah. And we need to write tests to make sure all of these methods work. So that's my context. And if we just focus in on the, let's say, the add product method, as a parameter, it expects to receive a product object or a product instance. And you can see it's doing some checking here. And if this condition is all true, then it pushes the product parameter that it got onto this array. Yeah. And it returns a true, otherwise it returns a false. So that's the actual implementation. But we said we should really start with specification. So let's supposing I didn't show you that implementation. Here's the specification for a particular method. So I've got a method that I need to add to my catalog class called the add product method. Its signature is, I should probably have been more specific here now. The signature is that it receives a product object and it returns a Boolean. And here's the specification. And I don't need to read through this because I've already kind of explained the method even by showing you the code. Okay, so this is my catalog, I suppose, is my target. And within that target, I want to test this add product method. It's a trivial method, admittedly, and whether you would really need to write tests for something as trivial as that, that could certainly be argued, but we have to start somewhere. Now, in terms of given when then, so I need to, the approach you would take is come up with your test cases first, kind of write them out if you want to. But certainly think about them and think about them following this given when then structure. And so that's what I've done here. And I've come up with 4 different test cases. Maybe I should just go back for a second. Maybe I should just go through this. So the method adds a product to the catalog. That's all right. Provided the product's ID is not is unique, as in there isn't already a product in the catalog that has that ID. And also the new product has to have a name property and it has to have a price. Okay, I've just arbitrarily decided this is the specification for this method. Okay, so there's obviously some conditions here that need to be met before the product is actually added to the catalog. And if all of these conditions are met, then the product is added to the catalog, but the method itself actually returns a Boolean true. If any one of the conditions are not met, then the product is not added to the catalog and the method returns a Boolean false. Okay, that's my specification. Then I came up with my given when then different test cases for that. And we won't go through, we'll just read the first 2 of them. So given that the catalog is initialized, that's kind of taken, initialized kind of in this case would mean that the products array has been created even though it's empty, right? When we add a valid product, so a valid product would be, it has a name, it's unique as ID, its ID is unique, sorry, and it has a price. That's just our shorthand for a valid product. Then true is returned. Okay, so I would write a test case. I would need to write a test case that implements this kind of given when then scenario. Another scenario, given that the catalog has some products in it already, when we add a product with an ID already in use, then false should be returned. And then there are 2 other scenarios as well, got to do with the product having a name and the product having a price. So from a testing point of view, I'd need to somehow write my tests to satisfy, to meet all of these different scenarios. Now, I could actually write the test code just as ordinary code and not bother using any testing framework. Okay, so if I was to do that, then let's go back to here. And here's, I've got a test folder and I've got a script called custom. Custom as in I'm not using any framework. And this might be my attempt at writing tests. So I'm just creating a catalog instance for myself, giving it a title. That's fine. I'm just creating some products. This is kind of my test data. And they all look like they're kind of valid products, right? They all have names, IDs. The IDs are unique. If you scan down through them, the names are fine. They all have a price. And I've created some kind of bad or error data, error product data as well. So I've got one here, and the product's ID is A124, but A124 looks like it's would clash with this one here. Okay, so if we try to add this product to the catalog and then try to add this product to the catalog, then it should reject the addition of this, sorry, it should reject the addition of this one and return false. And I've got another product here that doesn't have any price, and I've got a product that doesn't have any name. I've set name to the undefined value. And then I'm actually writing ordinary JavaScript code, but the purpose of this JavaScript code is to test my catalog class. So I've just got some nice kind of console logs so that when I run this, it will, look, I'll be able to interpret what it's telling me. And so if I just run it, yep, if I just run it. Now, the upshot of all this is that we shouldn't really take this approach. But if I just run that, so the output from it is kind of nice. It's telling me, look, the tests that I ran are tests related to the add product method of my catalog. And I'm saying when we add a valid product, then it should return. So this was just generated by a console log in my code. Let's maybe just look at this. Pull this down. So I had a console log of test that, that's fine. Then I have a console log of this, okay, which you just seen. Then I actually invoke the add product method of my catalog and I pass it product P123, which was one of the kind of well-structured products that I set up here. And I'm taking the response back and just doing an ordinary if statement on the response. If the response is true, then output this to the screen, otherwise output that to the screen. Okay, so when all of this executes, provided the method does return a response of true, then I know at this stage that, well, I've actually met the first one of my given when then test cases. I've satisfied number one. So my method is actually working for that. And then I would do similar stuff to see that 2, 3, and 4 are actually being met. And walking through all of the code. That's what the rest of the code in my custom test script is actually doing. Yeah. And the console logs is showing me anyway, it looks like that everything is passing. Okay, which is great. Although there's a failure here, which we would need to look at. When we have, when we add a product with no name, then it should return false. And for some reason, oh, sorry, that's passing. I beg your pardon. They're all passing. Surprise, surprise. Now, the only tiny issue with that add product is we should make sure really what we're testing is that this big long if statement, sorry, is coded properly, right? And so the only way you would ensure that it is coded properly, because there is lots of opportunities for mistakes, like you could be using, you could have used ors instead of ands, and that wouldn't have been right. You could have had nots on those, as in not product.name, but that's actually incorrect. So as simple, as trivial as the method is, there are possibilities of making mistakes on it, in it. But because I've written a whole series of tests using a custom approach, essentially my own code, then I've proven that the method is actually working. I know now we've only skimmed over the actual custom script, which is this one here. But it's nothing other than, just a long series, a long script that essentially sets up the data, invokes the target. The target in this case really is the add product method, and then if statements checking to see did the response that came back from my target, was it the response that I expected, and I'm console logging that. If it is what I expected, there's that word again, expected. My expectations were, for this one, it looks like the expectation was that it should return false, whatever the scenario was. And I just keep on writing more test cases using my own custom code. Now, there's how many lines of code there? There's 61, but I suppose we could take off the first uh, 15 or so, uh, which leaves it was what, about 46 lines of code, of test code for a target that had how many lines of code in it? Let's see. A target that had only about 4 or 5 lines of code. And that kind of reinforces the point I made earlier on that your test code can often be longer than your application code. But if you want to write good tests, then you can't really avoid that. Now, the point I'm trying to make though with writing custom code is that the code just gets very uh, long-winded and unmaintainable, really difficult to maintain. Because you can imagine if we started changing the criteria for products being added, then we have to look down through all of this script to find how do I change this custom test code so that it now meets the updated version of the add product target. Okay, so it looks like it's not really a workable solution. Therefore, we need to use a framework instead, a testing framework. And in general, there there are lots of unit testing frameworks, and there are lots of frameworks for the various languages out there, and I'm just mentioning some of them here. We're particularly interested in the JavaScript frameworks, and there are many of them. Probably Mocha was one of the original ones, and still extremely popular. Jest is a newer one that you might have heard of, But what you would notice if you looked at not just the JavaScript testing frameworks, but the other ones as well, they all pretty much follow the same structure and they use the same types of constructs. And so it's quite easy to transition from using one of these frameworks to using another one. I'm going to focus on the Mocha framework um, because it's probably the most used one in the JavaScript community anyway. And all of these unit testing frameworks, they all have the same kind of feature set, which is that I'm saying they impose a structure on your test code. Arguably, there wasn't really any structure in my custom test code. I could have maybe created some methods or functions within my custom script, but um, it still would result in pretty unmaintainable um, code. So these testing frameworks impose a particular structure. Initially, when I show you the structure, you'll think, God, that's pretty complicated. But after a little bit of usage of the framework, it actually becomes quite easy to understand the structure. Number two, they provided syntax for expressing uh, test expectations, and that can be quite useful. Again, it takes a little bit of getting used to using the syntax, but once you get to understand the flow of it, it becomes much easier to express expectations. Like in my custom script, the only way I was expressing expectations was just using if statements. And number three, they allow flexible running options. Again, if I go back to the custom script that I showed you there, I would add more code to that custom script for the other methods in my catalog class, and it would be just one big long script. And the only option I have is to run all of the tests in that script. I have no way of being specific about I only want to run certain tests. Whereas with these testing frameworks, you can actually narrow down which particular subset of test cases you want to run. So it has lots of flexibility in that sense. And I'm just trying to check my time. Okay, didn't get nearly as far as I was hoping to get. I may even try and cover some of this switchy tomorrow, as well as giving the intro to the lab. I'll think about it in the meantime, I suppose. For now, I suppose I should stop at this stage. And again, just to remind you, there will be a Zoom session tomorrow morning, starting at 9:15 before I let you work on the lab. Okay, I'll leave it there for now and I'll talk to you again tomorrow morning. Bye bye.